Waves for Young's slits, Young's double-slit experiment. Before we look at that, let's talk about diffraction. If waves go through a slit or waves go around a corner, they bend round the corner, they bend as they go through the slit, and you end up with plane waves turning into something more like circular waves. So basically a slit will act as a point source due to diffraction. How much the waves actually diffract depends on the wavelength compared to the size of the slit. For the best diffraction, they should be roughly the same size. But here, diffraction, waves diffract as they go through a slit. So if we have two slits, and here we're shining we're not up to two slits yet. If we shine a laser through a narrow slit, then on a screen we get a diffraction pattern. So the light diffracts as it goes through the slit and it spreads out on the screen. And if we use a more narrow slit, then it spreads out more. There's more diffraction. Now, Thomas Young, kind of more than 200 years ago, Thomas Young, probably the cleverest bloke who ever lived, carried out an experiment where he passed light through two narrow slits. What he was trying to do was show that light was a wave. He wanted to see interference, and he did. Very clever. Consider it was 220 years ago. Sunlight shines through a hole in the wall onto a mirror. He shines this light through a series of slits, a single slit to start with, and then a double slit. You don't need to know about the single slit. It basically makes sure that the light is coherent because it acts like a point source. But then it shines through the double slits, and then on a screen about a meter away we get something like this. With white light we get a white band in the middle, and then we get these fringes, different coloured fringes, and this is because the different wavelengths of light are interfering constructively at different angles. With a red laser, which is probably what you've done, we get this pattern, and again these are Young's fringes. What is very, very clear is that we are getting maxima and minima. We are getting interference, and this is pretty strong evidence, because nobody had thought of photons at that time, pretty strong evidence that light was a wave, and Thomas Young and Christian Huygens and Robert Hooke could all be very happy about that, and Newton wasn't. Okay, this is the equation for Young's double slits. Lambda equals Sx over L. And if you look at the diagram and I say to you similar triangles, and you should be able to figure out where this equation comes from. Look at the little triangle with lambda in it, and then the big triangle with x in it. X is the fringe separation. In practice, what we usually do is measure the distance between 10 fringes and then divide by 10. Because they tend to be very close together. Here's a question for you to do. Light from a red laser passes through two slits 0.2 millimeters apart. A pattern of fringes is seen on a screen 1.2 meters away. The fringe separation of 4 millimeters. Calculate the wavelength of the light from the laser. And that's the answer you should get.